Welcome to everyone for this case study in the topic Nepal Thermal Energy Efficiency Program Energy Efficiency in Industry. Myself N. Venkatesh, Additional Professor from Aeronautical Department in SNS College of Technology, Coimbatore. Introduction to thermal energy. Heat is the common name for thermal energy of an object that is due to the motion of the atoms and molecules that constitute the object, and energy in the form of the vibration and movements of microscopic particles. This is a heat conduction mode. There is a conduction, convection, and radiation. How it will be latent heat will be produced. This is a combustion. Combustion means it is a fuel and oxygen. It's oxidize and heats for the purpose of combustion. Combustion. First, what is meant by a combustion? Combustion reaction and heat liberation for 1 kg of molecule when there is a complete combustion. Calorific value. Calorific value is the measurement of heat or energy produced and is measured either as gross calorific value or net calorific value. The difference being the latent heat of condensation of the water vapor produced during the combustion process. Energy costs and heating values. These are the values and these are the types of energy and what are the gross calorific value, cost per unit and cost per case in given this diagram. Energy cost for dairy industry. Average specific fuel oil consumption of 8 liters per 1000 liter of milk for the reference year 2011 to 2012. Here the thermal equipments used in industries. There are the boilers, furnace, refrigeration, air conditioning and hot water are all some things will be used. Boilers will produce steam formations. It's the introduction of this session. It is an enclosed pressure vessel. Heat generated by combustion fuel is transferred to water to become steam process. It is called as an evaporation. Steam volume increases to 1600 times from water and produces tremendous force gas is must to avoid explosion. This is an example diagram of a boiler. It is the safety valve and chimney and dome will be here. This is the full construction of the boiler section. These are the typical boiler specifications used in this case study. It's a boiler made in year 2003. The name is XYZ. A MCR is a 10th FNA 100 degrees C. Rated working pressure is 10.54 kg per centimeter squared. Type of boiler is 3-pass fire tube. Fuel fired heating surface, fuel oil and M squared. Furnace. It is the furnace. How will be worked? We will discuss in the next upcoming slides. Performance evaluation of a typical furnace. Here is the heat loss industrial heating furnace. Gross fuel input and net fuel input. This is the available heat. Is the wall loss, opening loss, useful input and cooling water loss, or this is the conveyors. Introductions in a refrigerant deals with the transfer of heat from a lower temperature level at the heat source to a higher temperature level at the heat sink. It is the best application for the air conditioning for comfort and refrigeration for process. Ton of refrigeration. The cooling effect produced is quantified as a ton of refrigeration. 1 ton of refrigeration is equal to 3024 kilocalories per hour heat rejected. There is a vapor power compression cycle system. Here it is a condenser and evaporator and high temperature and low temperature values are in a presence in here, and how it be working and what are the functions will be occupied in vapor compression system. In the vapor absorption refrigeration system, there will be a condenser and generator and evaporator, and one absorber will be used here. This is the difference between the vapor power compression and vapor compression refrigerant system. So energy accounts for a significant share of our manufacturing cost. The water heater will be used for steam formation. This is the losses occur in a boiler. The first one is the dry flue gas loss, H2 loss, moisture in fuel, moisture in air, CO loss, fly ash loss, bottom ash loss. These 8 losses will be occupied in a boiler operating systems. It is a methodology of in this given diagram is the collection of relevant reports on energy efficiency and energy added for the input of the private sector energy utilization from surface losses and the fly ash loss. This is the trial data from this case study. We will get output. Flue gas temperature after air preheater is 750 degrees Celsius and ambient temperature is 40 degrees Celsius. Preheated air temperature is 190 degrees Celsius. Specific gravity of oil is equal to 0.92. Average fuel oil consumption is 400 liters per hour. It's calculated in 368 kg per hour. Calorific value of oil is 10,000 kilocalorie per kg. Average O2 percentage in flue gas 12%. Weight of stove 6000 kg per hour. Specific heat of billet 0.12 kilocalories per kg per degree Celsius. Surface temperature of roof and slide walls 122 degrees Celsius. Surface temperature other than heating and soaking zone is 85 degrees Celsius. Furnace efficiency direct method is a fuel input 400 liters per hour. Heat input is 368,000 kilocalories. Heat output is 936,000 kilocalories. Efficiency will be 25% approximately. Losses will be 75% approximately. This is the performance assignment of the in this given case study. The specific power consumption kilowatt per hour is a useful indicator performance of refrigeration system by measuring of refrigeration duty of the kilo performance is used by refrigerant energy format. The refrigeration is assessed in TR is equal to QCP into T input minus T output divided by 3024, where TR is a cooling tier duty, Q is mass flow rate of coolant, Cp is coolant specific heat, Ti is inlet, To is outlet temperature. This is energy added instruments. Instruments play a vital role in energy added categorize and quantity energy. To conserve energy, it is necessary to know how and how much energy is being consumed. Instruments also provide a means to monitor equipment performance and check condition. In order to arrive at the quantitative assessment, several fixed and portable instruments are used to measure the parameters related to energy consumption data, efficiency related data, operation and control data. Various energy added instruments are thermal, mechanical, chemical, electrical and lighting. Temperature can be measured by thermometer, thermocouple and indicator, thermograph, data logger, pyrometer and gyrometer. These are the mechanical measurements of Van meter, Vita tube, ultrasonic flow meter and multifunction kit. Yes, the chemical measurements are oxidizer, fire kit and flue gas analyzer. These are the ultrasonic meter. Its application is a measurement of liquid. Parameters measure velocity and discharge of fluid flow. Magnetic and it's airline manufacturing. The range is 0.1 range 0.03 to 12.12 meter per second. This is the ultrasonic flow meter. Its the range is 1 to 0.0232. Number of sets will be given as 1. It's made in Japan. Flow measurement of liquid is that application. And the next one is ultrasonic flow meter, and the next one is multifunction heat. It's made from Germany. As the temperature, humidity and thermal mechanical properties will be measured from here. The range is 0.4 to 16 meter per seconds. It's a non-contact tachometer stroboscope. It is parameters measured for speed of rotating the element. It's made from Germany. The range is 20 to 20,000 rpm. It's a tachometer. It's used for applications measure of speed, and that number of sets will be given as 1. It's the digital anemometer. It's made from Lutron, Taiwan. Its the range is 0 to 30 meter per second. Application is measurement of air gas velocity. Anemometer it is. It's the digital hot wire anemometer. Application, it's gas and air velocity will be measured. It is made from England, and the range is 0.25 to 30 meter per seconds. It's a gas and air pressure measurement. It's a measurement of static, dynamic and total pressure in gas and air ducts. It's a leak detector. It will be a air leakage. It's the digital pressure gauge. Application of a measurement liquid, gas and air pressure. It is a pressure type. Then pressure and vacuum gauges are used for measurement of pressure. Thus the range will be a 0 to 21 kg per centimeter square. It's a digital temperature and humidity data logger. Its range is 15 to 150 degrees Celsius and 0 to 99% of heat. And the parameters measured the application of dry bulb temperature and humidity. It's a temperature data logger and non-contact type infrared temperature indicator used to measurement of the surface. The range is 18 to 870 degree Celsius. It's an infrared pyrometer. It's used for measurement of surface. The range is 18 to 870 degrees Celsius. And thermocouples is used for measurement of temperature. In the minus 15 to 400 degrees Celsius ranges will be developed and measured from these thermocouples and thermometer indicator. It's a digital temperature indicator. It's used for measuring temperature, and the range is minus 50 to 1200 degrees Celsius. It's a digital temperature and gyrometer. It's a dry bulb temperature, humidity, and it's made from Taiwan. And the digital temperature and gyrometer. Then sling gyrometer. It is used for dry bulb and wet bulb temperature can be measured. Range is 0 to 50 degree Celsius. It's a combustion test. Measurement of flue gas quantities. It's a parameters carbon dioxide and oxygen. And the range is 0 to 20% carbon dioxide and 0 to 21% oxygen. It's a flue gas analyzer. It's a measurement of temperature and carbon dioxide in flue gas paths. The range is 0 to 21% and up to 10,000 ppm. Then is a combustion gas analyzer. It's a application measurement of flue gas measurement. Its range is 0 to 25%. So flue gas analyzer, it is used for measurement of flue gas parameter, and the range is 0.2 to 21%. Energy monitor is the range is 16 ampere, 250 volt, 4 kilowatt. It's used for measuring of single phase electrical parameters. The phase power analyzer, it is the application of measures all electrical and harmonic parameters measured in first 50 harmonics. Is the range is 830 volt to 3000 ampere, and the number of systems is given here is 1, and the phase meter as the scope of the industries will be used here for measuring electrical and harmonic parameters. Then the sample size of the required sample size, when we check the error margin of the breakdown of the machine, it will be rectifying that solution. Here is the phase power analyzer. It will be used for measure all electrical and harmonic parameters, and it's made from Canada. Its the range is 600 volt to 1000 ampere, and it will be very useful for measuring electrical sectors. The final stages of this Nepal electrical generation is from based on the thermodynamics of and the thermodynamics laws are zeroth law, first laws and second law. Mainly we are focusing the thermodynamics principle. It is thermal energy is converted into a electrical energy from mechanical energy. The mechanical energy will produced from a turbine, and that turbine mechanical energy is finally converted into the electrical energy. This is the best example of this case study. Mainly focusing electricity manpower is the material will be gypsum type will be used here. The final one is the areas and potential savings of this power plant are we are given in that next video.